Hello everybody, I'm Nick, and in this video I'm going to show you how Microsoft, with the release of .NET 6 and C# 10, really took string interpolation to the next level with the addition of interpolated string handlers. Now this is a pretty advanced topic, but I'm going to do my best explaining every step of the way how your application just instantly benefits off of being upgraded to .NET 6, and this includes your own code, library code, and .NET code, and also how you can actually write your own interpolated string handlers to do some pretty crazy stuff, so stay tuned for that. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out nickchapsas.com. So let's take a look at what I have here. I have a small console app which already has benchmark.net installed to run some benchmarks, and the only thing that it's doing is it is running that pre-configured benchmark. Now, before I show you the code, I want to show you that this project is actually running in .NET 5 and C# 9. This is important. I'm going to explain why. We're going to do some comparing here. So here's the benchmark and here's the code, and it's using a memory diagnoser. And what we're doing is we have a few different ways to build a string. We have the string.concat method. We have the string.concat with toString on the integers. We have a normal string concatenation here. We have a string builder. Then we have string.format, and then we have string interpolation. Again, this is all in .NET 5 and C# 9. Now, what I'm going to do is run this project. So let's go ahead and run the benchmark and wait for a minute and see what the results say. So results are back, and as you can see, in some cases we're matching both performance in terms of speed, like these two, and also memory. The string concatenation method with the string concat is the slowest. I'm going to explain why. And then the string builder is pretty fast, actually the fastest out of all of these, but it's not the most memory efficient. So we have a combination of all these memory allocations and speed. What I'm going to do is I'm going to save a snapshot of those results, put them here, and then what I'm going to do before I explain in depth why this happens is I'm going to change this project to .NET 6 and C# 10. And this is the only change I'm going to make. That's what I did. Now I'm going to go ahead and run those benchmarks again and see, just by upgrading to .NET 6 and C# 10, what difference in performance in both speed and memory I'm getting, just for upgrading the version. So results are back, and let's see what we have now. So as you can see, and let's actually compare that to the others, in every scenario, the .NET 6 and C# 10 is faster, but what's very important is actually the memory allocations. So the first 5 haven't actually changed, but you can see that the last one is more than double, almost triple actually, in memory efficiency. And in those numbers, these small nanoseconds, memory will hurt you way more than this small duration. So just by upgrading to .NET 6, you can see how more memory efficient string interpolation is. Now, why does this happen? Well, I'm going to explain why it happens. Let me show you something. I'm going to go back to .NET 5 and C# 9, and I'm going to save and go on this last one. And now in Rider, I can actually hover, and as you can see here, this is calling the format method. So the string.format method, and it's accepting a string format, and then it has a few object arguments. And these arguments are the integers you're saying, 1993, 6, and 9. So this means that what really happens behind the scenes is that string interpolation is being converted to this exact thing that you see here. And the problem with that is that this is using an object. And an object as a parameter here, when you're sending an integer, means that your integer will be boxed. Now, the integer is a value type that should normally go on the stack. However, it has to be put in a box to go in an object, which will be a heap allocation. These allocations are expensive, and this is what .NET 6 is fixing. Let's see how it's fixing that. So we're going to upgrade that to .NET 6 and C# 10 and go back. And now if I hover, as you can see, this is no longer a string.format. It is using the default interpolated string handler. What I'm going to do is I'm going to use sharplab.io to show you the lowered code, basically what the compiler would generate in both cases if we give it that code. Here we go. So as you can see, the first string.concat will actually make an object array, and then each item will be put in the object array, which means that value types like the integers here will need to be boxed. That's why it's the least memory efficient out of all of them. It's because everything just goes to the heap and it's getting boxed, and it's a lot of memory allocations. However, the toString approach here, where the integer is getting converted to a string, is more memory efficient because now the array is a string array, because the compiler actually detected that, hey, you're concatenating only strings here, so I don't need to box anything. here you go, get the memory efficient version. Well, as memory efficient as strings can be, but it's trying to optimize. And actually the default string concatenation with the pluses, what it really does behind the scenes is the exact same thing as you see here. It is making that array, it is setting each item in the array, and then it's using the concat method on the array. So you can tell that these are not really super efficient things. Now, string builder is a string builder. There have been things that changed due to that interpolated string handler addition, but nothing really that you can see in this example. And now in the last thing over here, you can see that the string format method here is basically not changed. And then that the string interpolation down here is being changed to a string.format. Now, if I go and I choose this branch over here in SharpLab, this will use the .NET 6 and C#10 changes. And as you can see, this is a whole different thing now down here. This is now using a default interpolated string handler, and it's doing some append formatted and append literal. And we're going to see what that is, by the way. And it's returning a toString and clear on that string interpolated handler. So there's quite a few different things happening under the hood. Let's take a look at them more closely. So why is it more efficient? Well, actually, if I use riders decompiler and I go in here, I can show you what happens behind the scenes. So you might remember two method calls. The append literal, this is called to actually append a string value as it is. And it has some span usage and some pretty small stuff that we're going to ignore. And then we have the append formatted method. And this is, if you remember, the other method that was called. Now, here we're using generics. This is very important. When you are using generics, the value will not get boxed. It will just be its own self represented by the generic, so an integer in our case. So what happens if I go to the benchmark and I bring up the IL viewer, which will show us the intermediate language code, is that for integers, for example, 1993 here, it's going to call the append formatted method with the int32, which is the int, as that generic parameter. And this will prevent the boxing that we saw in the previous approach with the format, which saves you the memory allocation. And then the append literal to append the backslash, I think it's a backslash, forward slash, the slash over here, won't need that because you're just appending a string. So that's how it manages to optimize it. And the way this basically works is it gets whatever is in that interpolated string and it says, oh, I have an integer. I'm going to call the append formatted method with that generic. And actually you can see it here when I hover over this part of the code, it says append formatted is called. Then if I hover over the string here, you can see that it calls the append literal. And then if I go forward, it calls the append formatted again, and then again append literal. So the methods of the handler, the default interpolated string handler, will be called to save you the allocations as part of that string interpolation. It's super clever stuff. And they're actually open. You can take that logic and build your own interpolated string handlers. And we're gonna do that to make something super, super efficient. Let me show you. So I'm gonna go ahead here and create a new class, and I'm gonna call that ensure that. It's effectively a guard class. It will allow us to throw when something is not what we'd expect it to be. So public static void ensure that it is true, let's say, and we're gonna have a boolean here, a condition, and we're gonna check against, and then we're gonna have a string, which is the message in case of a failure. And we're gonna implement that. So effectively it is just if condition is false, throw new argument exception with that message. And then for a parameter name, I'm actually going to use the caller argument expression, which allows me to point to a condition to get the name of the actual expression that was given. If you don't know what that is, I do have a video coming, so don't worry about it. But for now, just know that any value or expression that will be passed in this boolean will be captured as a string in compile time and can be used in the exception here. So I can just say param name here equals this, and then the compiler will do the rest. And I'm gonna paste that here, and that's it. And now watch what happens. I'm gonna go to the program, I'm gonna comment out this benchmark. I don't need it anymore. I'm gonna change this to debug, and I'm gonna say ensure that it is true. And what I wanna check is, let's say that date time dot now dot day equals I don't know, 18. So today is the 18. So let's say that it equals that, and the error would be that today wasn't the 18. So let's use a little bit of string interpolation here, right? So that's what we have, and I'm gonna go and run this. And as you can see, nothing happens because it is the 18 today. So, well, an exception wasn't thrown. However, if I say that this is the 17th, which was yesterday, and I go ahead and I run this, I'm getting an exception, and I'm getting exactly why I got the exception in that parameter name. Today wasn't the 17th, and I'm getting the parameter name being the expression that I checked against. Now, here's the problem with this. This is a guard clause, which I really hope would never happen. It throws an argument expression or an argument null expression or any sort of argument in range expression, which should be an edge case, an exceptional case that should not happen. My example might be bad, but in a more realistic case, it might be that the dependency is injected correctly in a class and so on and so forth. However, I really don't like the fact that whether this succeeds or fails, I'm going to have to allocate a string here. I really hate that. Of course, the default interpolated string handler will optimize this little boxing happening over here with a day number, but I still don't want to have to allocate that string when the thing doesn't actually fail. We can actually fix that by writing our own interpolated string handler. Let me show you. So I'm going to call that ensure interpolated string handler, many letters. But anyway, that's just a class. It doesn't need to inherit anything. What it needs is an attribute, and that is to mark it as an interpolated string handler over here. And then we're going to need a constructor, and that constructor will need an integer for the literal length. And then we're going to need an int for the formatted count. These are the only two things you need. Something that I should mention is that this should actually be a struct. And we can actually turn this into a ref struct. The benefit of this is the ability to also allocate it on the stack instead of the heap. And we're going to back this up with a default interpolated string handler. So behind the scenes, we're going to have an inner handler to back up our own handler because we don't want to write everything. We don't need to. And we're going to say new default interpolated string handler here. And we're going to pass the literal length and also the formatted count. And of course, this needs to be a new. Now, just by doing that and nothing else, let me show you. We can go ahead and copy that. We're going to go to the ensure that thing. And instead of a string, we're going to use a ref ensure interpolated string handler. There's a reason why this fails. We're going to fix it in a second. But for now, just know that we replaced that string with a ref of that interpolated string handler. So if I go back to that thing over here, remember that we had a few methods. First, we have to override, or we should override in this case, the toString, and we can say inner handler dot toString, and we can actually do the same with the public string toString and clear method. So we can say return inner handler dot toString and clear. So these two will allow us to actually do this, a toString here, to create the string out of that interpolated string handler. Now, as you can see, this thing here doesn't actually compile. It tells me that there's no way to actually handle the literal and there's no way to actually handle the integer. So all we need to do is create a couple of forward methods. So we're going to forward the public void append literal, and this accepts a string message. Here we go. And this will just call the inner append literal method. That's it. And then public void append formatted. And that uses a generic. It is a T message. Here we go. And then inner handler.append formatted.message. That's it. And now if I go back to my program.cs, as you can see, this thing actually compiles. So we sorted that problem because now we can handle both the literal and the integer through that generic. You can actually customize this behavior any way you want. We won't go too deep into this. But for now, just know that we actually just made our own interpolated string handler. However, we don't really get any benefit out of this because we still allocate the full memory for that string when this line is traversed. We want to prevent that. And that's exactly what we're going to do now. What I'm going to add is a couple of more properties here. The first parameter I'm going to pass is a condition. So I'm going to say bool condition. And the reason why I do that is because we really only want to do anything with this line over here when this condition is false. So all I need to do is go on the itisTrue method, and I'm going to say, and the biggest problem with this whole thing is how long the name is, but interpolated string handler argument condition. So now this will allow me to get that condition parameter in my ensure interpolated string handler here, and this will be populated. And also I can have a boolean, which is an out parameter called should append. And watch what happens now. I can do the following. I can say if condition, so if this thing is true, then the handler is just default. We don't care about it. And then should append equals false. So do not append that string that you see there. Else initialize the handler and say should append equals true. And here's the magic with this. If you do that, what will happen behind the scenes, and I will actually need to go to sharplab.io again to show you because IL is hard to read. What happens now, and you can see I've just copied the whole code, is that the ensure interpolated string handler that we just created is going to check whether that condition is true or not to drive the should append parameter. And if it actually throws, then it's going to append both the literal, the string, and the formatted int parameter, preventing the needless allocation of any string used in here. We can actually benchmark that. So what I've done is I updated this and show that to have the one that doesn't actually take into account the interpolated string handler argument, and it just uses a string. And then we have the smart way where we do actually take it into account and we only write when we need to write, when that thing is actually going to fail. And then what I did is I wrote a couple of benchmarks, and today is the 18th, so I don't expect this to fail. And we're gonna see how this will perform when you don't expect this to fail at all. So let's go ahead and change that to release and run this benchmark and see what we get back. So results are back and let's see what we have. So as you can see, the first takes 137 nanoseconds and allocates those 96 bytes of memory, while the one with the custom interpolated string handler allocates 0 memory because we never actually do anything with this line of code over here. It never fails, so it should never be allocated in the first place. The power that something like this gives you is insane when it comes to writing really high performance applications. And Microsoft has already started using this sort of thing already in their code. In fact, if you now try to do a debug.assert, you'll see that there's an overload for an assert interpolated string handler. And we'll actually do something very similar to what I just showed you. So you can have those debug.assert statements, even though they're being removed when the application is in release mode, you might still be running tests in debug mode and a bunch of other things. And you might want to have those debug statements, but you don't want to take the performance hit. So it is an amazing feature that I'm really curious to see what Microsoft will do in the future. It is a bit clunky, you know, you have to kind of know that you need an interpolated string handler attribute here, and you kind of need to know what parameters are accepted and what are not. But once you understand the basic structure, you can do some really advanced stuff with that. It's an awesome feature. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.